So yeah, welcome back to this lecture. And this lecture is kind of awareness lecture where we only talk about that why we need to use GPU or graphic card when we doing training of our artificial intelligence model. So in the deep learning space, everyone knows that with a decent experience that we need a graphic card to train a artificial intelligence model, or basically a medium to large size of artificial intelligence model. And when you enter the industry, you always need to create a decent to large size of artificial intelligence model, so you need GPU. So everyone know that they need GPU to train artificial intelligence model, but what's the reason behind that we need to use GPU? What is the architecture of GPU that's differ it from CPU? So that's make GPU the better player in this artificial intelligence training as compared to CPU. So let's look at that. So first of all, let's talk about that. What is CPU and what is the architecture of CPU? So basically, CPU is a chip that integrated in your system, in your basically cabinets or computer. So this is how the CPU looks like. This basically a chips. There is lots of billions of transistors inside this chip, that on and off the signal of 0 and 1. So you also know that this is a very basics. You also know about this in the high school. So this computer or this CPU is great at doing logical tasks, like doing a very logical computations, or running the software, running the threads in the background, running different software, and etc. So as you can see that CPU do process one by one because CPU expert in logical tasks, not high computation tasks. Eh, so for example, you have a very fast car, but on that particular supercar you only have two seats, and on the other side you have a slow trucks, but the capacity of the truck is very high. So the fast car is CPU that's have high speed on doing calculations and operations, but the storage is very low. And on the second hand, you have this truck which have generally little bit lower speed than this car, but the storage is very high as compared to the CPU. So for example, you are training your artificial neural network in your CPU. So when the calculation happen here, or this matrix calculation happen here, so you have a supercar with only two seats, so there is a limited number of calculation you can do. So let's take an example. For example, you want to train an artificial intelligence model, and we know that this is the neural network, and this is the matrix multiplication happening in the neural network, and this is the bias, and we get our final output. So there is a limitation in this CPU. You can do only a single or basically couple of matrix multiplication at a time. Means for example, you execute a matrix multiplications in your code. The matrix multiplication is sent to your CPU, and through this bus. Now this passage is called bus in or system bus, in which you send the signal to your CPU. Now on this bus you can only send one or two maximum number of matrix multiplication operations at a time. Now this is just basically an example to demonstrate that what is the difference between CPU and GPU. So for example, in this arrow or in this bus, you can only send two matrix multiplication, or basically 1 to 2 matrix multiplications only. Now the CPU execute the matrix multiplication with a very high speed and send the observation or send the output to our code. Now, as we know that in artificial intelligence training, there is lots of like millions of matrix multiplications happening. Now, if we send only 1 to 2 matrix multiplications at a time, it's take a while. It's take a long time to train this artificial neural network. And CPU basically is very slow in training artificial neural network. That's why CPU takes a lot of time for training, and big neural network unable to train on CPU. So if we train GPT on CPU, will never released. So you can assume that if we train GPT in CPU, and GPT basically have billions of parameter or billions of calculations, and if we do calculation like this one by one, we basically need years or maybe decades to train the artificial intelligence model on CPU. So that's the drawback of CPU. Drawbacks is basically a supercar with two seats only. So their speed is very high, but their storage is very low. So we can do very less matrix multiplication at a time at one pass in the system bus. So that's the drawback of our CPU while training our artificial intelligence. Now you can train very small to small model in CPU, because this is CPU can handle this model very easily, because this model only contain few operations and few parameters. So CPU can also easily handle the parameters or calculation of this model. But if your model become a little bit larger, you cannot train your model in CPU with a very high speed. It's need a lot of time to train on CPU. So that's the drawback, and that's the main reason why we don't train our artificial intelligence on CPU. Now here is the cure of it, the GPU. Now this is how GPU looks like. Basically this is NVIDIA GPU, a very advanced GPU. Now what does the GPU do? So for example, in the previous case, we have a supercar with only 2 seats, a truck with relative a slow speed as compared to this supercar, but have a very large storage that can carry information or lots of information at one pass in the system bus. Now this is only a visualization where I show only the 4 matrix multiplications. There is thousands and millions of matrix multiplications happening at once. So for example, this is our truck. This GPU is our truck that's carrying lot of calculations or matrix multiplications on their container, and they send all these matrix calculations through the system bus at once. So you can imagine in this CPU case, we only can do few matrix multiplications at one pass, at one system bus pass, like in this case. But in this GPU case, we can do lots of matrix multiplication at once. So it's leverage the parallel computing task. So it can do matrix multiplication parallelly. So for example, if we send, let's say the capacity of this GPU is 2000 matrix multiplications at once. So it can do 2000 multiplications or operations, or basically mathematical tasks parallelly. One task take 2 seconds. These 2000 tasks also take 2 seconds, because this task happening simultaneously and parallelly. And if we send this task to our CPU, this 2000 task one by one, and every task taking 2 seconds, so the final time is taken by the CPU is 4000 seconds. And in this case, we only take 2 seconds. So there is very large difference between this 4000 second and 2 seconds. So you can imagine that how fast this GPU is. And GPU is also, and that's why GPU is called a gold mine in this artificial intelligence space. That's why everyone is running to buy a lots of GPU. And NVIDIA is the big player in this GPU, and NVIDIA have basically 80% market share in the GPU market. So that's why 95% of artificial intelligence models that are currently in the market is trained on NVIDIA GPU. So GPU is specially made for high computation math works like graphics, processing, matrix multiplications. I also demonstrate that how these things happen. And GPU process multiple data in parallel as compared to CPU that process one by one. So that's the big difference. CPU process data one by one. So it's wait until this task is completed of the one process or one operation. After that, it send the result. Then second task is sent to this CPU through this bus, system bus. And after the output is calculated, then the third task, then the fourth task, and this happen one by one. But in this GPU case, all these things happen parallelly or simultaneously. So we don't need to wait very long time for our AI training completion. And GPU is also used for gaming. And why we use gaming? Because gaming includes lots of graphics, and graphics includes lot of matrix multiplications or lots of geometrical multiplications. And if we do gamings in CPU, you can also observe that the system lag very much, or basically your FPS is very low. So that's why GPU is also used for gaming, widely used for gaming, because GPU leverage the graphic processing unit, or basically it's process the graphics in our game, or do matrix multiplications that running behind our game or graphics. So yeah, that's the case on GPU that differ it from CPU. Now that's how GPUs looks like. So this is A100 GPU. Now this is the most popular GPU that used by a lot of companies, and also OpenAI use this A100 GPUs. Now the cost of this GPU is nearly $14,000, which is very expensive as compared to the household GPUs like GTX and RTX. But the cost is high due to its computation power. it can perform millions or billions of calculation at once. So you can imagine that how fast is this A100 GPU or graphic card. This is also provided by NVIDIA. So from this we can also say that NVIDIA is a monopoly in this graphic card industry. Second, we have Tesla, NVIDIA Tesla. So this is not a company, Tesla automobile. Basically, NVIDIA have another graphic card known as Tesla. So this is also very powerful in graphic card in AI training. Then we have Titan. Now this is a graphic card this is a graphic card named Titan. All this graphic card is integrated in the data centers where the company train their particular AI, or basically in the CPUs. So there is a chip on this. You can see that there's a chip, and we plug this chip into our CPU in our CPU in our data center, or anywhere we like, or anywhere we want to train our artificial intelligence model. Now here is a graph that show the difference between CPU and GPU. So as you can see that this is basically the GB per second, or this is basically the speed of the y-axis is basically the speed of GPU and CPU in GB per second, that how much data it can process. So this blue line is a graph of CPU throughout the time. So we have this Woodcrest CPU, this we have Bloomfield CPU, we have this Ivy Bridge, and this is all our CPUs versions. As you can see that the growth is very normal as compared to this GPU. Now you can see that this GPU growth is very drastically increased. So at 2013 the performance of GPU is here something like 340 GB per second, and the performance of CPU is only 60 GB per second. So there is a very large difference between this GPU and this CPU. And this GPU is GeForce 780 Ti. So this is very old GPU now, and today in 2023 this graph is increased by a very large factor, and this CPU graph is increasing with their normal pace or speed. So from this graph we can see that GPU basically outperforms CPU in artificial intelligence training and graphic rendering, or graphic matrix, or doing mathematical tasks that happening behind graphics. And it is also used in Bitcoin mining, because Bitcoin mining needs a lot of computation, lot of heavy computation that happens simultaneously or parallelly. So that's why lots of Bitcoin miner use this GPU, because if they do Bitcoin mining with CPU, their CPU basically blast. So if you want to know more about the GPUs, the architecture of GPUs, if you want to deep dive into the architecture of GPU, you can check out these resources. I also paste the link of paste the link of this article in the resources tab or in the description tab of this lectures. So if you want to deep dive into the GPUs architectures and GPU things, you can just visit this article. And if you want to see the actual difference between CPU and GPU by videos that is provided by NVIDIA and their official channel, you can visit this YouTube video and see that how this NVIDIA show the illustration that how GPUs differ from CPU. So this is basically very exciting watch. I also watched this video and I amazed with the result. So you can just see that particular video and enjoy the information that provided by NVIDIA in a more fun manner. So yeah, that's all for this lecture, and I hope you get the intuition that why we use GPU instead of CPU. And yeah, that's all for this lecture. Until then, bye bye and enjoy deep learning.